All right, hello everyone. You're welcome once again to our Python programming course. Like I mentioned yesterday, how many of you were able to install the matplot library? I gave the commands um, on WeChat, but I forgot to put it on WhatsApp. I put it this morning, so I hope that we've all been able to. For those that are on WeChat, you've been able to install this package. Okay, good, good. And I think James, you had a problem yesterday. Has it been sorted out?
Yeah, I did it all over again and it worked. I'm okay.
Okay. So, because I noticed that your, what do you call it? The weather condition, the last one didn't have an eye. If you check
Really?
again, you see,
Oh, okay.
yes, the condition you wrote there, it was more of conditon or something. There was no eye. That's why.
Oh,
That's why I
okay.
always advise that you copy your variable names and paste so you don't make mistakes if you want to type them.
Yeah. Thank you.
All right, all right. So today, let me share my screen. Today we'll be working on plotting. So let me quickly share my screen. Um, yeah. If you can see my screen, let me know so I can start the class. Can you see my screen? Can my screen be seen? Yes. Awesome. Awesome. All right. So let me share this. Yes, like I mentioned, one of the key aspects of programming is how to visualize your data. And it plays a critical role. And also for those that will go into analysis and all that, and even to your audience, sometimes if you put information in the form of a table and you share it, sometimes it becomes very difficult for them to actually appreciate or visualize what the table is trying to tell them. However, if you're able to plot them, give them graphs in the form of charts, in the form of histograms, pie plots, and all that, it really, really, really helps communicate what you want to do. So today we are going to look at plotting. And for now, I'm sure most of us have been able to, finish up with the assignment that I gave. And if there are any questions, like I said, just put them in the chat, and I would be happy to well attend to them whenever I see them. And also, I'm positive your friends will be happy to help you as well. So let's dive in. All right. So the theoretical aspect of this part will be very short because it would be more of a what do you call it? It will be more of practical. So basically, in Python programming and any other, dispensation, when you want to communicate, sometimes communicating with text is not able to send the information that you want to send out. So you would want to put it in a form that people can actually visualize and see the impact of what the information you're trying to churn out is having. So in basically in numerical computation, one essential part is the visualization of data. One approach to data visualization is plotting. And in plotting, we have the pie chart, the bar charts, the histograms, the line graphs and all those. And but then the unfortunate thing is in Python, there are no built-in functions for plotting. So the reason for that is Python comes in as very lightweight. When we download it, I think it was a few megabytes. When you install it, it's a few megabytes. So all these packages are not within Python when you install them. So Python is trying to make it such that it is always, pay as you go or something, use when you need. You don't have to come with all these packages and it will be on your PC and you will not be using them. An example that I can give, MATLAB is a very good, programming software, but it's very heavy because all these packages come pre-installed All you have to do is just call them or import them into your work. But for Python, it's not like that. So you only install what you need. And in this case, one of the commonly used visualization libraries is the matplotlib. Okay, and matplotlib is just the short form of mathematics plotting library. Okay, so they just put the abbreviations of all of them, matplotlib, and you have it here. All right. It should be noted, however, that the choice of library is based on the requirements of the data as well as what you expect to output. So keep that in mind. The choice of, because within, like I mentioned, in libraries or modules are like huge libraries. So if you go in there, you might have sessions within sessions. Okay, so you would probably go to the section where you have the chemistry, and within the chemistry section, you might even find several grades. Maybe you might find high school, you might find, um, you know, undergraduate, postgraduate, and stuff like that. So even within the library, there can be sessions. So in our case, um, I mentioned that mathematics plotting library, abbreviated as matplotlib, has several libraries within them. PyPlot and PyLab are the most commonly used. So we'll look at that. However, we would focus more on PyPlot, and you see how we use PyPlot to, reproduce our data and also make our audience visualize the information you are trying to communicate. Several types of plots, such as line graphs, histograms, pie charts, and bar charts, will be treated in this interactive session. We will look at how to introduce legend, label, titles, and all that. So we look at how to play around the graph, make it look more appealing, and how to make changes. There are times that if you want to publish an article, they have some very strict guidelines as to how the graph should look like. The font size and all those things. So we look at how we are going to work on all those ones as well. So today we are going to hop in right away. Oh, um, sorry, how many of us were able to install Matplotlib yesterday? How many? You just put a yes or a no in the chat. Right. Let's open our Jupyter notebook. We have the command prompt. Right. So I can see um how many people we have 9. Okay, that's good. That's good. Very good. There's a no Wilberforce, so you'd have to install it. If not, you may not be able to follow with the class today. Do you have the information that are you on the WhatsApp or WeChat group? Wilberforce. If you are on there, you should go check it out, and then WeChat. So you should see it. Look at the information and start installation. It takes a while, so it's better you do it now, so you don't miss out on what we are doing today. But you can have it run in the background and still follow the class anyway. Okay, so we go to our folders. Yeah, notebook. Now we create a new file. We call it plotting. Yeah, I'm very lazy with naming, so I choose the most convenient thing that comes to mind. So I go with plotting. We are done. Okay, so with this, we would have to import the libraries that we need. So you notice that in most Python programming scripts or files that you see, right, you notice that they start with the importation because the initialization part of the code has import in there. So because these libraries are what you'll be using, you can't use something that you haven't imported. So an example is, let's say we've not imported NumPy, right? And we want to use NumPy. What happens is if I type, let me just have an array, okay? So I call it plotting data. Okay. There is a question. Let me see what is happening. Let me see the challenge we have here. You wrote lip, not a P, it's a B. That's why you have that error here. Yeah, this is not a P, it's a B. In order not to make these mistakes, I usually recommend that you copy and paste. Copying and pasting usually helps, so you don't make certain mistakes. All right. I hope the fonts are large enough for the audience. Can you see the text, or should I increase the text size a bit? Should I increase the text size a bit?
Yes, sir.
Okay. So, yeah, I think this is better, a lot better, right? Okay. So we say np.array. See what happens. You will notice that we may not, and so I just give my array 1, 2, 3, 4, 5, 6, 7, 8. Just this, right? When I run this without having importing numpy, this is what is going to happen. Yep, MP is not defined. If I change this to numpy, it will still give me the same error. So that is why you always see that they import everything right at the inception of the script to make sure that all these scripts can be used within the code. So we have to first of all import numpy as np. Then our next line we import matplotlib. But the issue is that we want to use the module called pyplot within matplotlib. Okay, so if we want to, let me see, there is a yes, yeah, we'll look at that. So the issue is we want to import matplotlib is like the larger library. So for example, you want to read books on only chemistry. If you import the whole library, what is going to happen is you would have the books on physics, history, geography, which you don't need, which might make your code heavy and run slower. So what you do is, in order to pick exactly the section that you want, so that you can use the packages within those sections, it is best to also, use the method, okay, and pick the section you want. So you can either say matplotlib dot pyplot. So then what this is happening is go into matplotlib and pick only the pyplot module for us. And because this is too long, okay, because if you import this, what is going to happen is anytime you want to use this, you would have to type the whole of this. This is too much. Sorry, you have to type the whole of this, which is too much. So what we do is you give it an alias, and usually they call it PLT. So in most codes, you are going to see numpy as NP and matplotlib as .pyplot as PLT. This is one way of importing the pyplot library. Others also do it this way. It is not wrong. Somebody would also say from matplotlib import pyplot as PLT. So you see the difference. Someone will choose to go this way, and someone will also choose to go this way. So this is the same as go into this part, this it means there's a problem with your internet. You see, it is telling you that it is trying to connect. It's not able to connect. To check if your internet is connected. If not, I would advise you connect, or probably usually installing these modules. I always advise you put off your VPN. It makes it faster, especially when you are in China. Okay. All right. So we can either choose to go this way or go that way. They all work. So you don't have to worry your head about it. So I just want you to see, so that in case you see these two, you don't get confused. In some codes you see this, in some codes you see that. But they're all the same thing. They're doing the same work. All right. So we run this. Then now we run this. It says numpy is not defined. So why are we having this error? Who can help me with this?
Because we have defined numpy to be NP. So we have to
Good.
replace that with NP.
Yes, that's a good one. That's a good one. So it says MP. Yeah. Yep, that's how you do it. Upolampo, your hand is up. Let's hear you.
Yeah, I want to ask whether we should import both the NumPy and this one, the math. Should we import both of them together?
Yes. You need both of them. These are just two. There are sometimes
Okay.
can we import as many as 10 packages.
Oh, okay.
I think Gabriel, is your matplotlib done installing?
Yes, it's done installing, please.
So yeah, it will just load. Don't worry, it will take some time. I don't think it's a problem. All right. So now that we've observed the error, we just run it again, and we are good to go. All right. So the most simplest way to do is just write. There are several functions within the pyplot library that we can call. The first that is most commonly used is the plot method. So we say plt dot plot into bracket, we call our plot data. So what happens is, if you give it only this data, it chooses this as the x-axis, the data here as the x-axis, and then automatically gives you the y-axis based on its own metrics. So if you run this, you're not going to get anything. The reason being that you have to inform matplot library to actually show the plot. So you would say plt dot show. Then, because it's a function, we bring a opening and closing bracket, right? So now let's run this and see what happens. It gives us an empty array. Okay, what is happening? Let's check. Let's debug. Okay, let me see what plotting data looks like. Oh. Exactly. So what we have here is, you see, this dimension, okay, is not what we are looking for. So this is like an array within an array. This is like a multi-dimensional array, but that's not what we intended to do. This is what we did here. We made that mistake here. Right? So we just have to change it. So for example, if we want to see the shape, because it's a numpy array, we can say shape. Let me see what happens if you are going to get does not have shape tuple. object is not callable. So then it means that for the tuple, we don't have this. Oh, let me see. There is a command for getting the shape. Yes. So I don't bring this here. So you see, it is 1/8, but that's not what we are looking for. So we have to change this. Then we run this again and see what we get. Aha, so this is the right way. Then now we plot. Yeah. So we have the plot working perfectly for us. So this is the code that I ran to get the plots going. You had a straight line, Samuel Mensah. Yeah, let me see what you did. Yes. So you see, in your case, right, you see how you initialize the numpy array. You give it only 1 square bracket. In my case, I gave it 2. So it was a multi-dimensional array. That's why the plot was not working. Yeah. So I just had to change it. Now I can check the shape of it, and then it will tell me what it is. Before, the shape was what? 1/8. So that is where the challenge was. Yeah. So you are right. You did it correctly. Okay. So now that we have done this, you can see that our plot is very plain. This is just a simple plot. So what if we want to plot, we have an x. Say our x may be even number or odd numbers, I don't know, and want to plot something interesting. So let's just, all right, so we have x. Because usually in plotting, we use a lot of x and y's. After doing this, pip install, should I run this? No, 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 no. One is enough. You know, for some people, the pip does not work. So I provided the second alternative for them. I remember some of them were having challenges with the pip. So for them, you have to write Python 3 minus m, then you bring the pip install. Okay, so it's not for you. Even if you run it, it's probably going to tell you that it's already installed. So you don't need to. Okay.
Thank you.
Yep. You have it installed. You don't have a problem. All right. So now in plotting, usually we use x and y's. Okay, so let's create our x data. For plotting, it could be a numpy, it could not, doesn't really matter. Okay, so we just put together an array. Let's just use numpy as always, so we don't face any future issues. All right. Then let's choose, the first 6 or 7 odd numbers, right? And let's see how they propagate. Okay, so we can say 1, 3, 5, 7, 9, 11, and maybe let's end at 13. Okay, so we save this. Then now our y, we want our y to be the squared of this. Okay, so we see y is equal to x squared. Okay, run this. We are good to go. Now we plot. Start with plt dot plot into bracket. The first will be the x, the second y. Then we show, because if you don't show, it is not going to pop up. Show. All right. So let's run this and see what we get. Yeah. I have to probably reduce the size so you can see. Yeah. So this is how a graph of what do you call it? Odd numbers against their squared looks like. So you see that this graph is very ordinary. What if we want to we want to see the markers, the dots, along the slope of the graph? Let's do that. So now we introduce a new command. So most of these things, all I'm doing is showing you the barest minimum or the basics of it. But most of it you have to do by yourself. You have to learn the new commands, new ways of doing things when you play around with it. So now what we are going to do is we would introduce a command, and this command is called marker. So for marker, there are several ways, there are several options for you. And how do you find out these options? Let's just go to Google. Let me hide this thing. It's blocked my view. All right. So we just go here and we type pyplot markers. So it is going to give you all the available markers. Okay. You see, so these are the commands for the markers. Let's just show. So yeah. So the dot means you would have the markers being dot. Okay. O means it will be a circle. S means it would be a square. This sign, is it ampersand or whatever? Yeah. It would give you a triangle. V will give you a triangle upside down, plus. All these ones are markers, okay, that you can use. You don't, like I said, you don't have to know everything or keep everything in your head, but just make sure you know where to find everything. Okay. So in this case, we just choose, we can choose between these markers and see how they turn out. Okay. So let's first of all start with the dot. Sorry, the dot. And let's see what happens. So we run this. Now you see how the graph looks like. See? Between the first one and the second one. See, this one has dots, dots, dots in them. So this is showing where the markers are, where the points are along the slope of the graph. Now we can try another marker. Okay, let's see how that marker works. For example, let's try the O and see how the O looks like. You run this. You see, I think the O and the dots pretty look similar, but just the O's are a bit bigger than the dots. So let me put, I think I have to start commenting my code. Yeah. So let's start with a comment. Let me put a comment here. So let's say, something like that. So you can just put anything there just so that it gives you an idea of what you are doing here. So we wouldn't change anything. Now we come here, we can write checking out markers. Right? So we see how the markers work. Now let's try the V and see what happens, how that one looks. You see how the V looks like? It looks like the triangle is upside down. Okay. Now we try the other one and see how it looks. Yep. You see now the triangles are pointing upwards. Okay. So there are so many things. Let's try one more, then we are done. The X's and the stars. So we can go change this to an X, and it's going to show us X like that, X's. And if we put the star sign there, it's going to give us the star sign. So these are some of the basic markers you can use for plotting. Now, we want to, we want to name the graph. So we need to have, labels for the graph, okay? So what we do now is come here. Let's copy the same thing. We are using the same graph anyway. So now we are checking out labels. Yeah. So we can say, let me make it bigger so we can see. All right. So now here, for this plot, we want to label it. Okay. So in this case, it might not be necessary to label because we just have only one line graph. There are some cases you have 1, 2, 3, 4 line graphs. So you want to have a legend that talks about these graphs. So that's where the label comes in. But this is just a single graph, so we might not necessarily need it. So let's just skip that part. And then now we want to have the plt.x label. And don't forget, the label has to be a string. Okay. So we have our x label is what? Odd numbers. Then our plt.y label. We just put let me see, square of odd numbers. So you can choose whichever one you want to put there, and then we run it. So you see we have the odd numbers, and let me reduce the size so you can see it. So we have the odd numbers and the square of odd numbers. So that is how you label your x-axis and your y-axis, okay? So now we want to add a title because usually for every graph, you need to have a title at the top, okay? So what we do is we just come here, repeat the same command. If I'm going too fast, you can slow me down, okay? So we can both, enjoy the class. We can all enjoy the class. All right, so let's go to title. So it's the same thing you do, but this time around, you just bring the next line and then say plt.title. Most of them are, the methods are quite straightforward based on how the naming is. Okay, so we title a graph, a graph of odd numbers. Let me just do it this way, odd numbers and their squares against their squares or something. Let me just do this way. I think there's one more D I have to put here. Then, so this is how you do it. Then we run this. So you see the title at the top. So this is where we started from with a simple line graph. Then we added, we added the abscissa, and then we worked on our markers. Then we added our labels, and then we add our title. So you see now the graph is taking shape. Okay, in some cases you would want to add grid lines. Grid lines help you to see the demarcation of the code well. You know where what is what. So we just have to use the same graph. Okay. Then we put plt.grid. You can, I don't know if leaving it empty might work or we put true in there, but let's leave it empty and see if it's going to work. If it doesn't, just put true in there. I want to see if it works. Yep, it works. So we don't need to do that. So this is what the grid lines look like. Okay. So now you can see where what is what. So you know between 8 and 10, it's 9. So you know this is around 9. And this is 75 to 100. And we can see that it is around somewhere here. So we can say maybe it's around 80, 81, thereabout, you know. So you can use this to actually help you see where exactly you are and stuff like that. That is basically what this grid line does. So we can say all right. So then now we have seen how these ones work. We have worked with only the what do you call it, the plot now. So what if we want to create a very comprehensive data set? We want to probably have several lines of code. Okay, we want to see how the squared looks like, how what do you call it?
Hello, sir. Please, there was a question in the chat.
Oh, there's a question in the chat. Okay, give me a sec. Let me see. Yeah. Sorry, I had hidden the. Augustine says I should slow down. Okay, I will slow down. All right, Morel. So does it mean always when plotting and labeling graphs, plt.show must always be at the last line of the code? Yes, that should be the last line of the code. If you put that at the last line, that's when it shows. Because if you put it, let's try something. Okay, it's a very good question. And for me, like I said, programming, you always try ideas that pop up in your head. Let's bring the plt.show to maybe somewhere here and see what happens. You notice it showed the plot, but it didn't include all the other things because those things came after the plt.show. Okay, so now they are standing by themselves without any data to show for it. You get it? Similarly, if we bring it, let's bring it. Similarly, if we bring it here, see what is going to happen. It's only going to execute the ones that came before it. That's all. So these ones will not have it. So what it does is that the plt.show shows the graph, and whatever comes before it is what it shows. If you bring anything afterwards, it's not going to show. So that is why we always put the plt.show at the last end. Okay. So I hope that clarifies your concern. Good. So with that, we are good to go. All right. Now,
yes, sir, I want to know, does the parentheses add any effect to it?
So let's see what happens if we remove the parentheses. So if you remove the parentheses, it brings all this. It's telling you some of these things that you have here. So usually, this is a function, okay? So it's always good to bring the parentheses. You can choose not to bring it, but for visualization purposes, it is best to just put it there to save you the hassle, okay? And you are good to go. So that's the only difference you get. Nothing pops up at the top for you, okay? All right. So now that we are done, we want to save. We want to save the graph, or let's try a more complex one before we go into the saving of the graph. So now we want to see how the different, types work. So for example, we want to see how squaring of the odd number looks like. We want to see how a linear transformation of it will look like, multiplying by a certain scalar. We want to see how dividing by scalar would look like. You want to play around it and see what works. So now we are going to have one x, okay, and then several y's. It happens when we are programming. Wait, sorry, when we are working. So let's come back here, copy this. We can just say check out multi-line graph. All right, so now we have to create our own, we have to create new x's and new y's, okay? We already have our x created, okay? Where are they? Yep, you guys should come here. So I would have to copy this guy and just put it all on one line this time around, so it doesn't look too, all over the place. So I'll just remove this and remove that. All right, so these are x, and then we have our y. Well, let me increase the fonts. All right, we have our y, which would be equal to, we said x squared, okay? Then we come to our, so let's call this y1, okay? Let's give this name y1. Now let's have y2, which is equal to, say, we multiply or divide it by 2. You can just do that. So we can say x divided by 2. All right. Then we can just say we can try something else. Y3. Any ideas what we can do for Y3? Sorry, this will give me the modulus. Yeah, I don't want that. Yeah. Any ideas for Y3 as well? Who can help? Anything? Any ideas to give to Y3? Something you would want to see? Okay, let's see. Maybe we can deduct some numbers from it or something. So you can see x minus 15 or something. Let's see how that also works. So now that we have all these done, okay, what we will do now is, yeah, there's a suggestion in the box. The square root of x, okay. So y minus 3. Okay, we can do all of them. So you can do the square root of x as well. So we go to 3, and then let's go to y4. Let's have y4, okay? And that will be x dot, I think it's sqrt in numpy. Let me see. Let me confirm here. We have square root. Okay. In numpy. Yep. So we can just have a look at it. Yeah. You can put np the square root, or you can, yeah, so we can just choose it this way. So we can do it this way or that way. So let's go back. This panel keeps, yeah, let me put it underneath here. Good. All right. So go back to plotting. Then so now we have to plot all of them. ELT dot plot now. So this one will be x, y1. Now we can change the markers to see how things work, okay? So we can give this y2 and then change this marker to O, okay? Y3 and change this marker to triangle. Y4, oh, sorry. y4, we can change this one to diamond, I think. This is a capital D, right? So now look at what is going to happen when we do this. Yes, so it doesn't have any command square root. So this will have to be np dot square root x, like that. So we are good to go. Run this. Yep. See our graph. The square is too huge, so it is shadowing all these ones. So how about we do something like this? Let's change this to that, so we can actually appreciate all the graphs. All right. So now this is what the graphs look like. Okay. So we have our odd numbers, we have our even numbers. This is how they all look like. But now what we want to do is, you notice that we can't differentiate between them. We don't know which is which. Okay. So which one is the square root, which one is the da 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 da. So what we do now is we have to create a label and then a legend for it. Okay, label for the plots, and then we print out the legend. So what we do now is we come here. Okay. Right. What do we do? Now we have to label them. We bring the word label, and then you put them, because it's a string, you put them in quotes. It can be single or double quotes, doesn't matter. So inside it, let's say label this X. So that's what we are using. The next one, we label it there you go, good, X over 2. Label it X minus 3. X minus 3. And then finally, we have square root. Root of X. All right. So see what is going to happen. If we don't call the legend, we are not going to see the lines. See, even though we labeled it, nothing happened. See, nothing happened. So if we want the legend, we have to specifically state it. So we just put it, it doesn't matter where you put it, but just have to come before the show to plt.legend. Right? And then you run this. Now you see the difference. So now it is telling you this line is X. This line is when Y, this line is when Y is equal to X. This line is when Y is X over 2, X minus 3, and the root of X. So now you can see the difference. So the legend, if you don't state where to post the legend, it chooses the best optimal place to put it. So it can be on the top left, top right, bottom left, or bottom right. But you can sometimes specify where to put it. Yeah, Popolampo.
Yeah, I wanted to ask, in the code that we are writing, you see at the down there we have plots y label a square of odd numbers, but now we have different y1, y2, y3 up to y4. So I want to know like the difference there.
No. This is just a title I give it, so you can choose it. You
Oh,
can
okay.
you can just say it. This is not, it's not like it's strict. This is just a title, so we
Mm,
can just change it from uh, no, so you can just say variations of odd numbers. That's all. And you are good to go.
Okay.
So that it's just a title that we give it. You can change it to whatever you want. You get it?
Okay.
Yeah.
Yeah, I get it.
Yeah. So this is how you go about it. So now you can plot several lines of graphs. If you want to add a grid that we already did, you can easily do that. You can put it anywhere before or after a legend, but it has to be before plt.show. So you can just bring plt.grid, and then we run it, and voila. See? So these are some of the things you can do. You play around the graphs and stuff like that. So let's look at. Are there any questions up to this point? Are there any questions? Okay, since we don't have any questions, let's try to do other things. So we can try to do our yeah, Popolampo.
Yeah, sorry. Yeah, when I plot mine, this one, the other line was skewed down there, so I didn't see how you were able to spread it
Oh,
across.
yeah, we changed it. So this is squared. The squared was too large. All the other
Ah,
ones were too small because the highest here is around 13 or 14. But for the square, the highest around, I think, almost, let me check here. The highest is around 175. So if you plot 175 and then you have 14, all the 14s will line up here and then 175 will be over there. So your graph will look very small. That is why I just changed this to X
okay,
so that I can see everything clearly here. Yeah. So now we want to save our plot. Since there are no questions, let me
Hello,
quickly.
sir. I have a question.
Yeah, some more.
Yes, for presentation purposes,
Mhm.
do we have to maintain the grid lines or we have to take it off?
No, that's what I'm saying. When it comes to this, and this is up to you. Like I said, it depends on what you want to do. So if you don't need the grid lines, you don't have to bring it. You understand? This is just for me to show you the various ways you can do things. So if there's someone here who needs to show his grid lines, then it's okay. If not, there's no need for it.
Okay.
You don't even need to bring however you want it. It is entirely dependent on you. Okay. All right. So we want to save the graph sheet. Okay, so we can perhaps we want to put it inside the maybe we have a PPT that we want to put it inside. We just have to save it, and it saves into the folder that we are working in. So let's copy these. Let me just change this. All right. Once we have this done, like everything else, you have to always bring it before the save plot. Okay, so we come here, hit enter, we say plt dot save, fig, like that. Then now you choose the figure name. It has to be, what do you call it? It has to be string, okay? So what we can just say odd numbers. So you can choose the file format. So you can either choose PNG. So we'll run through all of them, see how the PNG looks like, the JPEG looks like, and the PDF. So there are several ways you can save them. So let's run this. Yep. So we have the graph here. Now we go into our folder. We can go into our folder, or we can go back to our home. And we should see yeah, it is here. We should see this odd numbers. This is our graph. So we can open it in the browser tab, or we can yep, this is how our graph looks like. It's a PNG. If you go into our folder, we have it here, which we can open it and see how it looks like. So you can use this for, your papers, your presentation, or whichever one, whatever you want to do with it. That's how you save the graph sheet. Yes, so this is how it looks. Okay. All right. So now let's try saving it as a
So you can
PNG.
copy it from here.
Oh yeah, you can copy it from here. Can copy it from here. Like I said, I would appreciate it if you would raise your hand so I call you, so that it doesn't, interrupt the flow. If that's okay, just lift your hand and I'll be happy to call you. Okay. All right. So now we have it saved as a PNG. Let's try the JPEG version and see what happens. I know there are some codes that don't take certain file formats. So this gives you the option of saving in several formats that you want. Yep. So when we go back into our folder, we should see JPEG. So, yep. So we have a PNG, we have JPEG. So depending on the file format you want, you can always just give it to it. However, if you want to use PDFs, you need to include the DPI. The DPI is basically I think the display per inch or something there. So you have to include DPI if you want to save as a PDF. Okay. So for PDF, you can change this to PDF. Yep. But you have to include display per inch. If you don't include it, it's fine, but you might not have. It might look a bit pixelated and all that. So usually you just choose the highest DPI, which is 300. Okay. Then you can choose to have a padding. You can choose to make the background transparent. All those ones are there. So if you want to have a padding, okay, you can choose. You can use bounding box. This is the BB box. Okay, BB box is equal to then BB box in inches. Sorry, you have to add the the metrics as well. So BB box inches. So you can choose. There are several options that we have available. So in my case, I can just choose tight. And like I said, if you want more of this information, you just go online, right? Like we did here. So you can just come here and say pie plots like that. All right. Then you hit enter. It's going to give you all the available options that you have. You can read this, or you can just go with the, So you see, it's just telling you how to save it. So you see BB box. This one says style. So you can find out what are the alternatives. And with that, remember I said we can find out. So you can come here and then say help. Pie plot, right? And then you run this. So if you run this, you're going to see all the modules. PyPlot is not defined. We said PLT, sorry. PLT. Run this. We're going to see all the information about it here for you. Okay. You see everything here. You can just read all of them. You see the markers, the marker types, and all those ones are here for you. It gives you all the information you need, several information on how to figure. All these things are here. You can look at them, and then it's going to help you, plot your graph better. So much, information here for you to sift through, depending on what you are looking for. So you have your X minimum, X maximum, so you can set your X minimum, your X maximum, and stuff like that. We'll look at how to plot multiple graphs on the same graph sheet and everything. So today we are basically going through plots. All right. So now that we have this done, let's try other plots, because we've done all these ones. So let's try the histograms, the bar chart and all those ones. Okay. Yeah, Maul, your hand is up.
Yes, please. Otto, if you want to save it as TIFF.
We can just find out. I've not tried that before, but we can try now. So let's see. Yep. So basically what they are saying is that this one probably may not be able to do that. So you have to use another, what you call a module they have here. These things are not too complicated. You can do them yourself. But yeah, it looks like you can save it here. So let's give it a shot and see how it looks. Most of these ones, you just have to try them and, we didn't run this, right? So we don't have the PDF. So let's just run this. Then I think you can even add a transparent or not background here as well. So clear, transparent or something. Yeah. Yeah, we can just remove this. So for me, usually when a question pops up in my head, I just try it. I mean, what's the worst that could happen, right? All right, so we go into our folder. We check out all the files you have. So you see you have the TIFF, you have the PNG, you have the PDF, you have the JPEG. So all of them, we have them here. Let's open them and see how they look like. Yep, so this is how it looks like. Okay, so you can play around with these things. Okay, so let's go with the other types of graphs. So I would want to do a bar chart, a pie chart, and all those ones. Okay. Let's see how a pie chart will look like. So we go with okay, let's start with a pie chart. So for a pie chart, you would say plt.pie. Instead of plt.plot, you go with plt.pie. Okay. And we put in our details. Okay. Let me see what happens when we do this. Let's see, show plot, plt.show. Yep, always. It's like a very simple one, right? Very simple one. We run this. Yep. So these are our plots. Okay. And if you want a bar chart, just change this to bar. All these informations are out there for you to find out. Okay. So we need to have the height. So let's put y1. Let's see what happens. Yep. Play around it. So we see how it looks like. We can try y and see what happens. Because we have y in there. See, this is how it works. So you can also have a histogram. You can have a scatter plot. All these ones are there for you. So I'll leave that ones for you to play around with them when you want to do these plots. Okay. All right. I remember the one of us mentioned something that has to do with the loading files and all that. Should we go in there, or we should just go in, do more of the graphs? Yeah, Bulampo, your hand is up.
Yeah, for the pie chart and the bar chart, no, I tried not to add the PLT show, and the graph still is showed up. So I don't
Okay.
know if they have that exception.
Yes, they should have it. They should have it. They should have it. But all, like I'm saying, all these ones, right? You just have to give it a try and see how it works. Okay, plt.show. Let's read about plt.show. Okay, let's go back here and let's find out what plt.show does. Okay, so we go to help. Let's see what happens. So what did this say? None type true if self else false. Yes, if you this didn't give us much information. You can check it online and find out what exactly the reason for that happening is. But with the plotting, I think the show helps you to see what is going on. I don't know. Let me see. I've been using show for a very long time. That sometimes when you use it, become very complacent that you don't really find out what exactly the let's see. Okay, so whether you need PLT show depends entirely on the environment where you run the Python code. Good. So you must use PLT show when running matplotlib from a standalone Python script. Okay, so if you're running a .py file or an environment that does not have an integrated plotting end, like a standard Python IDLE. Okay, so in our case, the reason why it is showing is because we are running an environment where those ones, the IDE shows, they're able to show us because they have the integrated plotting back end. Okay, so you can see it from here. You can often omit plt.show when working in an interactive environment like Jupyter notebooks, like what we are doing now, IPython shell and IDs with specific configuration like VS Code, Jupyter, and stuff like that. The reason is that the environment often has an inline plotting back end enabled. Okay, good. So the reason for that is because of the IDE that you are using. If you were using maybe a different IDE that didn't have the integrated standalone, what do you call it, plotting backend, it wouldn't show. You understand? So that is why we do that. Yeah, Samuel, your hand is up.
All right. So, see, earlier on we plotted x against x1, y1 to y4. So in the case of the bar chart, I wanted to try if probably plotting all of them will give us a different image, but it came as one. I didn't see the separate Y1, Y2, Y3, Y4.
Okay, so I think it has to do with what a bar chart is or a pie chart is. Can you have a pie chart having, different Ys and all that? Probably
This one
not.
was specifically, I tried the bar chart only, not the pie chart.
Yes, I'm talking about okay, I thought you said it. So the bar chart as well. So maybe you can have several bar charts plotted on the same graph. That is the reason. That will probably be the reason. So you can find out. That's like I said, you don't have to know everything, but you need to find out everything. So if you don't understand, you just Google it and see why that. It'll give you all the information you need. Okay?
All right.
But I would believe that, it probably wouldn't work because the bar chart doesn't take that, or the pie chart, or whatever you're working with, the histogram. Maybe you don't do that. That is the reason for that. Yeah. All right. So we are going to look at loading data files, okay, and plotting them, right? So what I want to do now is, I think we first of all need to create a data file for plotting, then load it, okay? We are going to use NumPy to do all of this, okay? To create a data file, then we load it. Okay. So what we want to do now is let's generate like a space, all right? And for generating data, we have a command in NumPy that we call line space, okay? So we will just say our x is equal to lins space, okay, into bracket 0 to 0 to 10, and I want 100 points. So this is the starting, this is the ending, and this is the number of points you want, okay? And then our second line, let's work with trigonometrical functions so that we can have, something interesting plot. So our Y1, we call it NP. Oh, I forgot to bring NP. It should be a NumPy. Yep. It's within the NumPy library. So now we bring our sign of X. Our next line, Y2, would be NP dot cos of X. Want to see how they all look like. And then should we add one more? Nah, it's probably okay. So what we want to do now is we would want to save this data. Okay. Save this data. Right. So let's run this data first. Let's run this, and then we know that our data is okay. So let's see how our X looks like. Yeah, we have 100 of them. So we can just check the length of X to see if it did what we wanted to do. Yep, you have 100. Similarly, I'm sure if you have Y1, all of them would look the same way. Yep, same way, 100 of them, good. Now we have, their dimensions are matching, so we wouldn't have a problem with dimensionality. Now let's save this. So the command for saving in NumPy is np.save. So with the .save, right, there are several options that are available to you. So you can save it as a text, you can save it as a CXV file, all these ones are there. But usually I would advise you always save your files as a CSV file. Okay. So now we are saving it. So let's call it what the name we want to give the file will be maybe metric data dot CSV. So there you have to add a file format to it. Okay. Then what are we saving? See, if you want to save this, right, you have to put all of them together in one file. So in a two-dimensional array. So that we'll save it, it would look like a table, right? So if we want to do that, we first of all have to convert this into that table form. Okay. So let's do that. Let's do that. And then how to do that is we would have to put, we call it, have row stack or column stack, depending on how you want to stack it. If you want to stack it row-wise, it will stack it at the bottom downwards. Okay. And that's not what we want. We want to have several columns. So we would have, let's call it a data set or maybe data. And say np dot column stack, all right, into bracket. Which one do we want to have first? So we want to have all of them within, sorry. So let's say we want to start with the first row, the first column should be our X, right? The second column should be our Y1, and the third column our Y2, right? So when we stack this, now see how this looks. Our data. You see now it becomes a multi-dimensional array. You have this here. The first column is this data, about 100 of it. You have the next column, all the way to the end. Okay. So we see this is our X, this is our Y1, and this is our Y2. Okay. All the way to 100. Good. All right. So now the data we want to save, we just put information here as data. This is the information we want to save. So if it was another name here, we would have just changed it to whichever name we give to this data set. Okay. Now let me reduce the font a bit so that I can see what is going on. Good. So with this, you have to choose. You see, CSV, you can choose several ways of demarcation. Okay. In some cases, you can choose space, comma, full stop, and stuff like that. But the best approach has always been the comma. So you bring the delimiter here, which is how you want to, separate the values. So we put comma. Okay. Then now we want to have headers for all of them, because we want to put the headings for all of them. So we want to have the heading for this one. Okay, this one should have a heading. This one should have a heading, and this one should have a heading as well. Okay. So what is the heading? So it's called the command for that is header. The header is equal to let's pick, because we said it's comma delimiter, right? We have to use X comma for the first one. So now the X would be the heading for the first column. The second column we say sign, right? Second column is sign. And the third column is what? Cosine. Yep. and the limit, it has to be an I. Yeah. Okay. So with this, we are good to go. So let's run this and see if we did everything right. We should have it saved. Good. Voila, it's saved. So when we come into our folder, we should see this. This is the information we just saved. Okay. So let me just open it so we see what information we saved. Yeah. No, I don't want to convert it. So you see how I save it. We have X, we have our sine, we have our cosine. Okay, so it saved it nicely for us. Yeah, good. All right, so now that we have that done, now we want to call this data. So this is an example of a file that you saved. Okay, you just drop the file here in your folder, but you need it. So you notice that the way we call this file will be dependent on where this file is. Okay, I would want to show you all of that. So here we can see that this file is in the same folder as the file we are working with. So the file we are working with today is what? Plotting. It's here. They are all in the same folder. So there's no need to bring several lines. Okay, so let's just load the file. Okay, so what we have to do is we can choose to load them and then give them out one by one. So we can just say loaded data. Okay. All this is not necessary in this way, but I just wanted to see how we save our data and how we load our data. Okay. So say np dot load txt. Okay. So you notice that the first one, when we're saving, we save txt. We are loading txt. Okay. What is the name of the file? This is the name we gave it. So we copy the same name. Yeah. And we can just run this and see what happens. So there's something that we needed to unpack and all that. Okay. So let me see the error we have. Could not retrieve a string. Okay, column 1. Okay. All right. So we have to skip row 1 because row 1 has text in there. From when I showed you this, let me just open it again in the. Let me open it in the. Open it with this one makes it easier. Quickly. So you notice that this first row are strings. So we don't want to load this one. So we have to skip it. Okay. That is why we had that error. So now we give it skip rows. Okay. We skip first row. Now let's run this and see what happens. And what is the next error we're having? Could not retrieve string. Why are we having this error? Okay, let me try. Oh, okay. We need to add the delimiter and see. Yeah. So the challenge was with this delimiter as well. So now we have this. So let's see how our data looks like. So these are our data. Okay. So what we can do is, if we want to plot them, we have to separate them into their various, categories, right? So we can say that let's use a capital X be equal to let me see if we can first of all get it right. Data.0 is what? No, this is not what we want. We want the entire column. Okay. So we've already done that, right? So we can just go ahead and try it. We want 0. No, we want all the rows, right? The slicing we did, but then we want the first column. Let me see what we get for that. Yep. So now we assign this to this array slicing that we did. I'm sure we all remember this from our previous class. So we assign this to X. Then obviously we do the same for all of them. So this one we call it Y1, and then Y2. And we change this to 1, and we change this to 2. So we have our information beautifully saved and withdrawn. Okay. Now we want to plot. I want you to help me plot this and give it all the information you want. So I'll leave this one for you briefly. Plot this information. Give me the information I need to plot this, and I'll plot them. I should go over the loading and saving again. Whoa. Okay. So let me delete this. All right, so we can be clear. So we generated the data, okay? And this is that data. We generated numbers from 0 to 10, okay? But then we want 100 different numbers. So then it means that we would have 0 all the way to 10, but then there will be 100 different numbers within intervals, okay? So we have 99 intervals with 100 numbers, right? And for those numbers, we wanted to find the sign of it and then the cause of it. So the sign is one plot, the cause is another. When we finished, we saved it. To save it, right, you need to save it as one, one data in the form of a table or, a multi-dimensional array. So in order to do that, these ones are separate. So we have to stack them. And in stacking them, we can choose to stack them row-wise or column-wise. But we don't want to have one long, a list, only one column with long data. No, we want to have each column representing each type of data we are working with. So the first column will be the X, second column will be Y1, third column will be Y2. So that's how we put it here. X, Y1, and Y2. So column 1, column 2, column 3. Now this is how we save it. So when you are saving it, you can choose several options of saving. And you can read about this. Most of these ones, the information are out there. Like I said, if you want any information, you just go here. And then you check it out. It will give you everything you need to know about so it tells you everything here. So you see it is telling us the format it takes. This is the file name, okay? And now this is the data. So do you want to format the digits to decimal places? This is up to you. This is where the delimiter, you can either choose the delimiter to be space or column, okay, sorry, comma. Then do you want it to drop on every new line? We have the header, the footer, the comments, and so these ones are there. And if you read them, it explains them for you here. The parameters, file name is that, all of them here for you. So every information you need, you can just type it here and you are good to go. Okay, so we did that and we saved it to the header. The first column we called it a second sign, and then third cosine, right? So now we have saved the data. When we saved it, we went here and we went into our file system, and then we saw that our file explorer has a file named trigonometric data.csv. This is the data we created. That's here. Okay. So now, let's say we didn't create a data, but you already have a data that you want to plot. Okay. So then you just load that data. And how do you load the data? You use np. Okay. So np.load data. This is we skip the first row because the first row has, what do you call it, strings, and it may affect our work. So we have to skip that first row. Then we move on to the next. So now we have the delimiter, which we assign here from the beginning. You can either use space or comma. But for CSV, it's mostly comma that we use. That's why it's called comma delimiter, CSV. Okay, so we do that. And once we've loaded it, now this data comes in a multi-dimensional array, which I showed you here. This data that we loaded. Okay, it's a multi-dimensional array, just like here. How we see it? No, this is not the file I'm looking at. Let me go here and then open it for you to see. So I opened it in Excel. Don't convert. All right. So you see inside Excel, the first column, right, has strings which we don't want. But the second column, 0, 0, and 1. This is where we want to start from. Okay. So this is the data that we loaded. Okay. Now, when you come here, you see 0, 0, 1. It loads it. So the first column here is the X, second is Y1, third is Y2. We want to assign them to their various, places. Okay, so we just load them and then say, give for the first all rows, first column, assign it to X, all rows, second column, Y1 and Y2. That's what we did here. However, loading the data, there is also another way you can do it, okay, which is a bit more easier, but not commonly used. But however, you need to add another command, which is unpack, okay? So we are going to do that, but we will look at that later. So once that is done, you have this data. Now we plot, and I want you all to give me the command for plotting these lines, and I want you to show me the legend, and then also show me the grid lines. So I'm waiting for you. Post your answers in the chat, okay? So I ran them. So all of us today, let's do this. Plot this data set. So you just need to plot X against Y1 and X against Y2. That's all I want. Okay, we have one solution here. Good. Save it as a PDF. Nice. So who else? Before I run this solution, I want to hear from someone else. Good. We see how it's going to look like. So let me give you till 1:40. Sorry, till 9:40 for us to see the other answers. 6 more minutes. I'm waiting. So after 6 minutes, I'll look at the chat and see everybody's answer. Yes, I have two answers from James. Another one, James and Elon. Anyone else? Real good. Polampo, yes. Yes, yes, yes. Great, 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 great. There are a number of us here. I want a few more solutions. I can give you what I've done so far to serve as reference, but that would be like a cheat. No, you guys should do it yourself. Let's see if you really understand. So we have 1 more minute, then I check out the answers. Who else? Good. Our time is up. So let's start with the first solution we got from Along. Copy it. And here we go. We run it. Let's see what we get. What we get. Okay. Let me reduce the font so you can see clearly what is happening. Okay. We have something. So you notice that you have this information here. The reason for having this information is you should have brought the opening and closing brackets. So in cases where you don't have plotting integrated into the backend, this will not work. It will probably not give you the graph. Yeah, so that is that. But yes, Elom has done it beautifully. We have the grid lines, we have the title. Good, 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 very good. The legend. All right, let's look at James's results. All right. James, I hope is this all your information? Okay, let me see. So James plotted only one graph. Okay. I was hoping you plot both of them. So yeah, it's a very good attempt as well. Because all of that information are in there beautifully. Let's look at Morel's. Morel made sure to load the data as well. So there will be no mistakes. I like that. So we run this and see how it looks. Yep. Very nice. Very nice. Same as alums. Very good. Very good. Very good. Very good. All right. So let's try Popolampos. I think at this point, you all have become Python gurus in a certain way. You can plot data and all that. Bro, you see, there's a problem here. And can you tell me where the problem is, Morel? Let me increase the size of your information. Looking at the error message, where do you think your problem is? Bro, if you're with me, I want to hear you.
I'm here.
What do you think the error is? Look at the error message.
The part that I said,
Uh-huh.
I didn't include the how do you call it? The quotes, that quote sign.
Yes, you didn't bring the
The ending
closing.
part in.
Yes, that's why I keep saying that when you open, make sure you close it and then you type within them so you don't make these mistakes. Okay?
Okay.
Yeah. But then, I like I said, the more you make mistakes in programming, the more you learn. So it's brilliant. Very nice. Very, very nice. Very nice. All right. So who is next? Who is next? Let me see. Popolampo, right? I just did Morels, right? Yes. So let's try Popolampos. So we all see how our graphs look. Here we go. Yep. Good. Good job. Good job. Good job. Good job. Very nice. Very nice. I like it. I'm enjoying myself. I feel like I'm being taught by all of you. I like it. All right. We have this is from AJ. Good. 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 Excellent. I like the way the graph looks catchy and all that with the colors and stuff like that. Eric, yes, Eric shared his. Good. The screen, good. So plotted just one. No, it's not. Okay, so James, you brought a new code. Okay, let's do this. Let's try a new code and see what happens. Yes, yes. Now, James, you have it right, but you forgot to bring the opening and closing bracket. So in cases where you don't have, if it's a Python file and you don't have, you are not running a Jupyter notebook, you might not see the graph. Okay, so yeah, this is a lot better. Now, Mauli, let's try Mauli's. Yep, good job. Yep. So at this point, I'm positive that we all, from what I'm seeing, I think majority of us grasp how to do this. So today was very fruitful. Yeah, 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 yeah. Great, 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 great. All right. Yep. Augustine added comments. I like that. Augustine says he's checking out, you know. Good. He's checking out multi-line graphs. Nice. Let's go. Let's see what we have. Augustine, are you sure you are working on what we are working on? You are giving me a different graph for Augustine. You should check and revert. This is not what we are working on. Finally, we have James. Somehow you are saying, why are you seeing only one line graph? Let me run it so we see. We all work on it and then see how we can correct it. I see two graphs. This is your code. I just loaded it. Samuel, are you there? Yeah, Samuel.
Yes, sir, I'm using a splitted screen, so maybe.
Oh, okay, because I can see the graphs here. I just copied paste here and it worked. I didn't do anything else.
Okay, thank you.
All right. And we have Andy's. Elam, your hand was up. Elam, can you hear me?
Yeah, I've typed my question in the chat.
Okay, sure. I'll have a look. Yep, you have it. Andy, yours works. Let me look at Abdul's. All right. Yep, Abdul. Are you sure you are plotting what we are plotting? Look at the your values. Are you sure there are small x and small y's? Check your variable names. Maybe that's the reason. Because this is plotting the previous graph, not the okay. Maybe in your case you did it small x. Okay. So just check them out. But
This is, oh, sorry.
sure, go ahead, Abdul.
Okay, I'm having a different graph here.
Oh, okay.
I don't know. Let me screenshot it and put it on this.
Yeah, it's fine. Depends on how you labeled, or sorry, the variable names you give it. Maybe you use small case, lowercase x and y's, but I use this. So like I think it's okay. It's okay. And how do you specify, choose the colors of the plot lines? Good, that's a good question. So let's do that together. So for the graph, Samuel, your hand is up. Do you have a question?
No,
Samuel
sir,
Mensah.
let me take it off.
All right, sure. So what you want to do is, let's say you want to change this. Python automatically chooses the colors for you, but you can choose your own colors, okay? So you bring, for every graph, you just choose color, okay? And you bring your quotes. So we can choose green for Jane, okay? Then color, yeah? You choose R for red. So all these color codes, you can find them within the, what you call it, within your, you can check them online and get them. Yep. So you see, we've been able to change the color. So if you add color, you can. So there are several, what do you call it? There are several methods here that you can use. So just check them out. There are several parameters in there. So if you want to see them, you can just type here, help plt.plot to see the several options that are available to you. Then you run it. So it is saying that it takes several values. You should see all of them here. Bool, all these things. You would have to go through them to understand, to get the full picture of some of the information it takes. This is even telling you how to plot them and all that. So you can try here are the parameters. This is what I'm looking for. So you have X or Y, which is for the graph, the format, your data, and it returns all these ones. So you can go through the help and you see all of these things. Okay. So you see the type of markers that are available. You see them here, the characters. Yeah, Elom, your hand is up.
Yeah, I don't think the plots they look good enough. Is there any other Python function for plotting better aesthetically pleasing graphs?
So there are several different modules that you can use. This is what PyPlot does. So you can, I think, Seaborn, there's a PyLab, there are several of them. So when you go online, you check out modules for plotting in Python. Okay, you can just check. Sorry, Python. It's nice aesthetics, right? It would show you. So you see, Seaborn is there. You see, so you can read about Seaborn. There is Plotly, there is Altair, there is Plot9, Matplotlib. This is what we are using. There is Spygal. So you can just look at all these ones. So this plotting brings the popular R library into Python. So the way it will plot, your plot will look like how it plots in R. You understand? So most of these things, you just go online. You can just get all the information you need. Like I said, you don't have to know everything, but you have to know where to find everything. It's very important. So yes, that's a very good question. Yeah. All right. Finally, we have Popolampo. Yes, Abdul, I can see that. Yeah. Popolampo, your hand is up.
Yeah, yeah. I said I want to ask when we save the file in the CSV and I open it with the Excel, it's showing that some features there is a possible data loss. Some features be lost, so
Yes,
it's better to save it in Excel format. So I wanted you to clarify that.
so you are opening a CSV file in Excel. That is why Excel is giving you that information. Okay. Because Excel would rather you save in Excel. You get it? So for that, saving most data that I know that I work with, usually they save it in CSV files. Okay. They don't save it as Excel sheets. And the reason for that is with CSV files, you can open with Notepad and read whatever it is in there. But Excel, it's a paid option, okay? So if you don't have Excel installed, then it means that you would have challenges opening Excel files to view, okay? So CSV is like the format that when I started programming, most of the files that we save them as CSV. But doesn't mean that is the only way of doing it. So in your case, if you want to save it at Excel, okay, you can just go online. Like I could do it, but I want to show you how you can do that as well. So you go online and say, save data as Excel in NumPy or in Python, whichever one you want to do it. So you have the information on how to go about it. If you can save the data as, so you see, so they are saying that you probably may not be able to do that with NumPy. So the efficient method is pandas, which is what we are going to do next week. So we'll look at pandas next week. So then you have to install pandas and open all these things to save them. You understand? Sometimes saving as Excel is also very cumbersome. So most often, files are saved as CSV, in my opinion.
Okay, so it means that if you save it as a CSV, you need to open it in your notepad.
Or you can open it in Excel. So Excel is just prompting you. You don't have to do anything.
Oh, okay.
Yes, yes. So what Excel wants you to do is convert your CSV to Excel. You understand? So you can play around with it. That is all what Excel is asking you to do.
Oh, okay, okay.
Yeah. Elom, your hand is up.
Yeah, if I might
Okay.
add to that, I think it's a good habit to get into saving your data as CSV because it's a more widely accepted format for most should I say software platforms. So for instance, um most applications or platforms where you use data, um they mostly let me say the CSV format is usually preferred. And it's not a problem if you open a CSV file in Excel because Excel can still take the CSV format. It just tries to like gently encourage you to save it as an Excel file. But typically people prefer to use the CSV format because it's more widely used and more widely accepted across different should I say software platforms, if I should put it that way. So just to contribute to this discussion.
Thanks for that. Thanks for that. So yeah, so basically that is how it works. So most of the files that I have saved in my programming journey has always been CSV. So yeah, so I would also encourage because sometimes when you are loading certain, information, the data type they would rather work with is CSV than Excel because of certain, complications that come with it. So yeah, thank you very much for that. So on this note, we are coming to the end of class. And the assignment, I will be sharing an assignment with you over the next few days. So you try it out on your own. But I would also encourage you all to install pandas before our class next week. But I'm not going to show you, I'm not going to give you the command to install pandas, but I expect you to have pandas installed. So how you are going to do it, I'll leave that to you. And I would want to know what are some of the challenges you would face when you tried installing pandas or, all of that. You can share your challenges in the chat, but now I want you all to install pandas for the next class, okay? So I'll share this file with you. And on this note, are there any questions before we end for today? Any questions? Any questions before we draw the curtains for today?
Hello, Mr. Johnson.
Yeah, sure. Go ahead.
Yeah, my question is not exactly related to what we did today. That's why we waited for the end of the class to ask. That's why I need your
Sure.
professional opinion.
Okay.
So let's say you're working with a very large data, maybe for example, transactions from a bank, and you are supposed to dress it up and get information from it. Which is it like more efficient to use Python or use Excel? Because maybe, for example, you might want to do a reconciliation, then get like some averages and you know how they do. So in this situation, will it be ideal to work faster to use Python or just go with Excel like that?
Well, for me, I would say it depends on what you are very good at, one, and two, it depends on the kind of what do you call it, the kind of operations or what you would want to do on the data that you are working with. In some cases, if you use Python, you have several room to do other things because like the modules that are available to you are so many. When you go online, you Google do this with Python, do that with Python, you would have several people. You even have people that have written codes that are doing what you want to do in the first place. But Excel, you are restricted to whatever Excel is providing and nothing more. You get the difference. So if you are doing certain things, yes, Excel is also a powerful tool. I'm not going to discount that. But the degrees of freedom for Python and Excel, I would say Python has more degrees of freedom. So if you are very good at Excel, I would suggest you go with Excel. And if you want to try and see the difference on the efficiency and all that too, you can try Python and you can try Excel and see how it works. But one thing about the difference is that Excel, you can visualize what you are doing. But Python, you would have to call whatever it is you are doing to see what is going on in the system. So yes, Excel you can use for, some one or two things, provide you some very good data analytical tools. But if you want to do like very, very strong data analysis where you want to perform, for example, you want to have pipelines that will churn the data and then brings out different forms of it based on different expressions and all that. Python is more, to me, would be the best option to go.
Oh, okay.
So
Okay.
yeah, so depending on your strength, okay, and depending on the time that's available to you, and depending on what you want to do, you would have to compare the two and then choose the right one for you. Like I said, there's no one way of doing things. But the most important thing is what you want to do and how efficient you want to go about it. That's all. Then it will inform which platform you choose. Yeah.
Oh, okay. Okay, thank you.
All right. You're welcome. So don't forget to install Pandas, everybody. See you on Monday. And I'll be sharing the assignment. I've noticed that when I share the assignment, I don't know if it's because it's weekends. We don't do it. I've included myself. We don't do it. So you don't feel like we don't do it. So please, today, when I share the assignment, try as much as you can. The more you practice, the better you get at it. And I can help you solve the problem. For example, James had a problem, right? And he put it out there, and then the answer was given. Some of these things, you just have to do it. The more you do it, the more you know some of the mistakes you make. Okay. All right. So thank you all, and then see you on Monday. Enjoy your weekend. Bye bye.